Imagine asking an AI to plan a trip while you are cooking. Halfway through its answer, you remember that your passport expires soon. You interrupt. The AI stops, listens, updates the plan, and starts checking passport rules in the background. Then it returns to the conversation without making you restart. That sounds like a small improvement to voice chat. It is not. OpenAI's GPT-Live, announced on July 8, 2026, is built to listen and speak at the same time. This is known as full-duplex voice. The important change is not that the voice sounds more human. It is that the AI no longer has to treat conversation as a sequence of neatly separated messages. That could turn voice from an optional chatbot feature into an operating layer for AI agents. To understand why, consider how older voice assistants worked. The original ChatGPT voice used a chain of 3 systems. First, a speech-to-text model converted your voice into written words. Then a language model produced a written answer. Finally, a text-to-speech model read that answer aloud. Speech went in, text moved through the system, speech came out. This pipeline was useful, but every stage added delay. It could also lose information. A transcript captures what you said, but not always how you said it. Hesitation, emphasis, pace, and emotion can become flattened into plain text. More importantly, the entire system usually needed to decide that you had finished speaking before it could begin answering. That decision sounds easy until you listen to a normal human conversation. People pause to think. They restart sentences. They say, "Book it for Thursday," then immediately correct themselves with, "Actually, make that Friday." They use filler words. They talk over each other. They make quick sounds like "right" or "mm-hmm" that show attention without taking control of the conversation. Traditional voice systems often interpret silence as the end of your turn. Pause for 1 second and the AI may jump in. Start speaking again and either it talks over you or its entire response gets cancelled. Even newer audio models improved speed without fully escaping this turn-based structure. The experience was smoother, but it still behaved more like a walkie-talkie than a phone call. One side transmitted, then the other side transmitted. GPT-Live changes that basic rhythm. A full-duplex system continuously processes incoming audio while it is producing outgoing audio. It does not simply wait for a complete message, generate a complete answer, and send that answer back. According to OpenAI, GPT-Live makes interaction decisions many times per second. Should it speak now? Should it keep listening? Was that pause meaningful? Is the user interrupting or just saying, "yeah," to show agreement? Should it stop its answer? Should it call a tool? Those decisions are the hidden mechanism that makes the conversation feel alive. Listening and speaking simultaneously does not mean the model should constantly talk over you. The real skill is knowing when not to speak. If you pause because you are searching for a word, it should wait. If you interrupt to correct an important detail, it should stop. If you say, "mm-hmm," it should understand that you probably wanted to continue. This is also why full-duplex voice is harder than simply making responses faster. A system that answers too quickly may feel aggressive. One that waits too long feels broken. Natural conversation depends on timing measured in fractions of a second, but that timing also changes between people, languages, and situations. If you enjoy clear explanations of the mechanisms behind new AI systems, subscribe. We focus on what the technology actually does, not just the launch day hype. Full-duplex interaction is only one half of GPT-Live's design. The other half may be even more important. OpenAI separated the model handling the conversation from the model doing deeper work. Think of GPT-Live as the person at the front desk. It listens, speaks, tracks the flow of the discussion, and decides what needs to happen next. If you ask a simple question, it may answer directly. If you request something involving web search, deeper reasoning, or several actions, it can delegate that work to a more capable model behind the scenes. At launch, OpenAI said GPT-Live could delegate to GPT 5.5. The voice model could keep the conversation moving while that second model searched or reasoned. Suppose you ask, "Can you compare 3 train routes to Chicago, avoid overnight travel, and check whether any arrive before my meeting?" A turn-based chatbot may leave you staring at a loading indicator. A delegated voice system can acknowledge the task, ask what time the meeting starts, and collect another preference while the search is already running. That is background reasoning combined with foreground conversation. It also means the voice personality and the underlying intelligence no longer need to be the same model. The conversational layer can be optimized for timing, audio, interruptions, and responsiveness. The delegated model can be optimized for careful reasoning, search, or tool use. future models can be swapped into the background without rebuilding the entire voice experience. This is where the idea starts moving beyond a talking chatbot. A chatbot waits inside a box for a message. An operating layer stays involved while work unfolds. You could ask it to compare options, clarify constraints, report progress, and request approval before taking an important action. The conversation becomes the control system for the agent. That could be useful while driving, cooking, repairing equipment, walking through an unfamiliar city, or helping someone who finds keyboards difficult. Live translation also becomes more practical when the system can follow both sides without forcing everyone into artificial turns. But there is a common misunderstanding here. Natural timing is not the same as human understanding. A well-placed can make a model seem emotionally aware even when it has misunderstood the situation. Recent research on real-time voice systems has found that models may respond mainly to the words while missing important signals in vocal delivery. Someone can say, "I'm fine," in a distressed voice, and the system may still act as if everything is fine. The interface can feel socially intelligent before the underlying judgment is socially reliable. That matters because voice has more emotional force than text. A warm voice that remembers details, responds instantly, and stays available can encourage attachment. OpenAI specifically tested GPT-Live for emotional reliance, self-harm, psychosis, manipulation, and other voice-related risks. Its system can steer or interrupt unsafe responses, and in higher-risk cases, end a conversation. Those protections are meaningful, but they do not remove the broader risk of people treating fluent companionship as genuine care. Spoken safety is also difficult for another reason. In text, a harmful answer can be blocked before the user sees it. In live speech, the system may already be halfway through a sentence when a safety monitor reacts. That is why real-time safeguards need the ability to interrupt output while it is happening. Then there are language and accent gaps. OpenAI says GPT-Live is optimized for some of ChatGPT's most popular languages, but it may have non-native accents or reduced fluency in others. Turn-taking can also vary culturally. A pause that signals "I'm finished" in one setting may signal "I'm thinking" in another. Privacy becomes more noticeable too. A voice assistant may hear names, health concerns, family arguments, or background conversations that were never carefully typed into a box. OpenAI's consumer controls allow users to decide whether audio is shared for model training, and voice clips have their own retention rules. Still, the practical lesson is simple. An always available microphone deserves more attention than an ordinary text field. Users need to know when listening begins, when it ends, what is stored, and what account controls are active. Cost may also limit the experience. Continuous audio processing requires ongoing computation, and delegated tasks may call larger models or external tools. At launch, GPT-Live had not yet reached the API, so its broader developer pricing was still unknown. The architecture is powerful, but running a conversational layer and a reasoning layer together is not free. And voice will not replace text everywhere. Text is better when you need exact wording, quiet interaction, code, tables, links, or a record you can scan. The likely future is not voice defeating text. It is voice becoming the main control surface, while text and visuals appear whenever they communicate the result better. That is the bigger mental model. GPT-Live is interesting because it treats conversation as a continuous process rather than a pile of audio messages. It listens while speaking, makes constant decisions about timing, and can delegate serious work without abandoning the interaction. If that approach succeeds, the chatbot box may stop being the place where AI lives. AI could instead sit across apps and tools as a conversational layer that listens, clarifies, acts, and reports back. The strange part is that the most important upgrade may not be what the AI says. It may be knowing when to speak, when to stop, and what to do while nobody is waiting for an answer. Would you want an AI that stays in the conversation while it works, or would that feel too intrusive? Share your view in the comments along with any topic you want us to explain next.